So let's just start out. Today we're going to talk about how Verizon adopted and is adopting Amazon Aurora for their enterprise workloads. And with me today I have Shashi Sherban and Sandeep Carrero, and we're going to talk about that. I'm actually very, very excited about this. We've been working with Verizon for quite a while, and given that we're a little bit behind, we're going to catch up. So the first thing I want to talk about is why are we even having this conversation? There's a lot of words about relational databases not necessarily being the newest, fanciest thing. But I think that all of you know that relational databases remain the core of every enterprise business. In addition, customers need flexibility in those databases. Many of the licensing models, many of the technology choices that have been made in the past are no longer appropriate anymore. And so we thought about that. And then the other thing is, people are moving because they really want to use the open source speed of innovation. I had the privilege of working at Oracle Corporation for 14 years in the database group. And I now have the privilege of being one of the members of the Postgres community. And I can tell you right now that the Postgres community innovates faster every week than the group I was in at Oracle. There are more commits, there's more discussion, there are more designs. And that's amazing. I mean, certainly when I sat inside Oracle, I wouldn't have thought that was true. So a couple years ago, about 6 years ago, Amazon talked about all these problems. We were offering RDS, and we kept having customers running into problems with the databases we offered. And we learned that what we really needed to do was reimagine the database. And so what we decided to do was reimagine it from the bottom up, where we took the storage level out of the bottom of the database and made it its own separate, self-healing, self-monitoring, self-managed service. And that is the Aurora storage system. And I believe there's actually a session on that here at the conference, which you can go find out. And the other thing that's interesting is it comes down to how humans and developers work, which is humans like to work on small teams, humans like to have small wins and small milestones, and humans of today and developers today, they love developing and deploying regularly. Well, these large monolithic databases don't lend themselves to that. So in Aurora, we actually have many different levels of innovation and many teams deploying different software, and so we can move a lot faster. So I'm going to hand over the mic to Sandeep. Sandeep has been working with SQL since late in the last millennium, and he's been working with large banks and telcos. And he then recently worked with the College Board and did a lot of work for their databases. He's been with AWS as a solutions architect for 2.5 years now, and he's dedicated himself to Verizon, I believe, and making Verizon successful. So welcome, Sandeep.
Thanks, Mark. Thank you for the wonderful introduction. Let's talk about what we are going to talk about today. We are going to start with a brief introduction on Verizon, and then we will dive deeper into how Verizon is keeping their systems up and running 24/7 on-premise, what different architecture patterns they are following on-premise. We're going to start with that. Then we will dive deeper into some of the key database requirements coming from Verizon for migrating their critical workloads over to AWS. We will see how Aurora Postgres meets most of the requirements that Verizon is looking for. So we will look at the feature set that Aurora provides today. We will talk about the migration patterns that Verizon is looking at for migrating these critical workloads over to AWS, as well as once these systems are migrated, how would they look in AWS? I've been with Verizon for over 6 months now, helping them design strategies around migrating these workloads to AWS. So we did a bunch of POCs with them. We are going to talk about one of them that was very critical in terms of the number of challenges we were facing in that POC. And one of the challenges we overcame using the new tool that just got released called Performance Insights. So we will dive deeper into Performance Insights as well and see how Performance Insights can help solve some of the difficult questions around which queries are running slow, when they were running slow, and then you move forward with figuring out how to tune it. Then we will talk about the different migration challenges that Verizon is having, moving from a commercial footprint to Aurora Postgres. Different features, different things that they are interested in. We are going to look at all of that. And then some of the nice-to-have features that are not there in Aurora today, we are going to talk about that as well. And then we will end the session with some of the updates for Aurora Postgres from Mark, and then Q&A in the end. So we will start with a quick intro. I'm going to have Shashi cover that for us. So Shashi is Associate Director. He's focused on leading Verizon's move to the cloud and to open source databases. Please welcome Shashi.
Thank you, Mark and Sandeep, for the great start. Hello, folks, and thanks for coming here. I have been with Verizon for almost 10 years, and being part of the Cloud Platform Services organization, most of the time I spend on the database portfolio for the wireless part of the business. And I manage and support most of the mission-critical systems for the wireless footprint, some of the applications like customer care, billing, IT finance, legal, and provisioning. So before we start the tech track, I would like to spend a couple of minutes on Verizon. So who we are. So we are part of the Fortune 500 with 160,000 employees across the globe and approximately $32 billion in revenue during the third quarter of 2017. So Verizon is a leader in the wireless industry with 115 million subscriber base, and we are also one of the largest all-fiber Fios network with 6 million customers. And most of you may know we are now transforming ourselves and our business into the digital media, IoT, and the broadband service. So what is Verizon really up to, right? So Verizon is committed to improve our lives, the way we live, work, and play, which is powered by its innovation towards the communication and the technology products. So having said that, to set the stage for this presentation, I would like to briefly talk about how Verizon has categorized the applications within the wireless portfolio. So we have three different categories: mission critical, business critical, and the non-critical. So for the sake of the presentation today, we'll be mainly focusing on the mission critical and the business critical. So what exactly do we mean by mission critical? So mission critical applications are those applications which support the core business function. They are directly related to the revenue and the customer service. Whereas the business critical applications, they are important, but they support the internal business function, and they may or may not be related to revenue and the customer service. As you can see, the RTO for the business critical systems are less than 4 hours, and for the mission critical application is close to 15 minutes. In the next slide, I'll cover some of the system architectures and high availability and the DR solutions that we have configured for this type of systems. So here is a typical architecture for a mission critical application. In this case, a database or an application is hosted on multiple data centers. In this case, we have 3 data centers, 1, 2, and 3. And as you can see, all the databases or the systems in these data centers are actively servicing the customer transactions at any given point in time. So they all are active and supporting the business. So one of the key things to notice is to make sure that all these 3 systems are active and servicing the customers, we need to have the data to be in sync across these 3 data centers. So we do have a third-party software that we are using to replicate the data, and the SLA for this replication is close to near real time. So one other thing I would like to highlight here is within the mission-critical applications, there are 2 types of workloads. One is the active-active. For the active-active type of applications, the entire database or the data is being replicated across the 3 nodes, and the data is not region-specific, and the transaction is serviced with, by any of these 3 databases available in these 3 data centers. And for the sharded workload, it is little different. It's more region-specific. The workload in each of the systems sitting in data center 1, 2, and 3 is region-specific, and only the reference data and the process data is being replicated across 3 sites for disaster recovery purpose. So some of the applications that fall into this categories are the sales application, billing, and the customer care. So here's a system architecture for a business critical type of system. So here you can see that at the database or the application is hosted on a single data center, and at any given point in time, only one of the database is active and taking the customer transactions. And for disaster recovery and HA purpose, we have the data replicated to the other data center. And we have one way, and one thing to notice that we also have a reporting database in place where we have a one-way data being replicated for analytics purpose. So some of the applications that fall into this categories are customer billing validation, which we are going to cover more in detail, and the financial application. So moving to the next segment of this presentation, I would like to lay down some of the requirements that we have from Verizon point of view for the Verizon systems and the applications to run in the public cloud. So one of the key requirements is the high availability. So the expectation here is we need to keep our systems on the applications up and running 24/7 by 365. So there are a couple of ways that we are doing it today on our on-premise databases, on-premise data centers. So one of the things is local HA. So we are providing a HA within the data center itself. So the way we are doing this is we are hosting the application on a cluster database nodes, and if one of the node goes down, the other nodes pick up the transaction and pick up the next incoming transaction, and the business continues. So this kind of local HA provides us security or provides high availability in case of the hardware failure, or if we are doing any maintenance like applying the patches on the database side or on the operating system side. So talking about the disaster recovery solution, here we are going outside the data center. So this disaster recovery solution comes into picture when we have issues with the cluster database itself, the entire database, or we have some issues with the complete database. So in this case, the transactions are failed over to the other available data center. And the way this is failover is, the failover triggers at the global router level, and the next coming transaction, if the database is not reachable on the data center 1, it is failed over to the second data center. So this is one of the key asks. A couple of more things on the key requirements. I just talked about how we are providing the systems and the data available across multiple data centers. But one other thing that we would like to see here is we would like to design an architecture or application in such a way that the failover is quick and transparent. We really don't want to impact the business and the customers for a longer period of time when we are into a disaster situation. So the ask here is, when we move to the public cloud, the application should be architected for a quick and transparent failover. Minimum code changes. So when we think of migrating our on-premise application and the system to the public cloud, we really don't want to rewrite the entire application code base, or we really don't want to massage the entire database to move to public cloud. So we are looking for a solution in AWS wherein I can minimize all these changes that I had to do on my end and kind of simplify the complete migration process. Hybrid workload. So some of the systems in-house that we have supports 2 different types of workloads. During the normal business hours, it supports the online OLTP type of transactions, but during the off-peak hours, those same databases switch into the batch mode because we do get the feeds from various interfaces, and we massage it and load it into the database for further processing. So when we move to AWS public cloud, we are looking for a database solution which can support both these type of workloads. Data security is the key. We have some of the systems databases which store sensitive data. The data is encrypted at rest, and as well as in transit. For the in-transit encryption, we are using a third-party tokenization software, and the ask here is when we move to cloud, we would like to continue using the same tokenization software, and we really don't want to introduce anything new and impact all the application footprint that we have. Patching process. So with the local HA architecture, we are applying the patches to the database and the operating system with zero downtime. But there are certain cases when we need to apply the patch at the cluster level or even at the operating system firmware level, there is a downtime required. So we are looking for some kind of option in cloud wherein I can completely eliminate this downtime for patching purpose. Database monitoring. So we do extensively monitor our databases. There are a couple of ways we do. We have our own homegrown scripts, and besides this, we also use some third-party graphical tools, which kind of gives an one-page view of the overall health of the database. But we can also, with a couple of clicks, I can go down all the way up to the SQL performance and as well as the OS metrics. So when we go to cloud, we would like to continue to have the extensive system monitoring. And the last ask here is auditing. As I mentioned earlier, like we have some systems or the database which holds critical sensitive information. So those systems are part of the SOX and the CPI compliance procedures and policy. So at Verizon, we are expected to send some periodic reports to them. Those reports basically contains a list of users who have access to the databases and what kind of tables or objects that they have access and how many times they have logged in and logged out from this sensitive databases. So the expectation is I need to have some kind of options and features available in the public cloud and so that I can continue to maintain the SOX and the CPI compliance procedures and policies. So this is the complete laundry list that I have given this to Amazon. Mark is laughing here, but yeah, that's a complete laundry list. I have given it to them. So let's hear from Sandeep, like what solutions we have in cloud. Sandeep.
Thank you, Shashi. Let's look at some of the key features of Aurora Postgres here and see how the set of requirements that just Shashi shared with us, how Postgres fulfills a lot of those. First one is scaling and load balancing. So Aurora does give the capability to scale the cluster up to 15 read replicas for scaling the read operations as well as for increased availability. For load balancing, there is a reader endpoint that the application can connect to, and that reader endpoint is readily available in Aurora Postgres. You don't have to configure it. That reader endpoint is giving you access to all the read replicas that are part of this cluster. Aurora is monitored automatically. Monitoring is automated for two main components. One is at the instance level for instance failures and failovers. The second one is at the storage level for storage failures and recoveries. We will talk about the failures and failovers in the coming slides. From tuning perspective, in traditional databases, we are used to tune the database either at the instance level or at the application level where you are tuning the queries to make sure they are running faster. Aurora cluster has been pre-tuned to work to run all kinds of workloads in the cloud without making configuration changes for different workloads at the instance level. From Sorry, guys, give me a sec. So from tuning perspective, the only thing the user needs to worry about is the query tuning now. You don't have to worry about tuning the database at the instance level. From storage perspective, storage engine has been completely redesigned in Aurora. It is a shared storage between the writer instance and the read replicas. Storage is spread across 3 different availability zones, and each availability zone keeps 2 copies of the same data for repairs and recoveries. As the data grows, the storage grows as well on demand. It grows up to 64 terabytes in size today per cluster. One key feature of Aurora is the storage system is transaction aware. The user gets an acknowledgement as soon as the log records are persisted to the local SSD. Rest of it is completely asynchronous. What that means is once the transaction logs are persisted in the local SSD, the data segments are getting updated asynchronously and in parallel with all these new log records that are coming in. Now let's talk about failures and failovers. Unfortunately, systems fail due to various reasons. It could be a power failure, it could be a network failure. In such cases, another node needs to get promoted to master to start taking the application traffic. Failover usually takes less than 30 seconds and is really dependent on the time it takes to propagate the DNS entry. And the failovers are transparent to the applications because you're always connecting to the cluster endpoint. It's just a matter of DNS getting updated there. There is no recovery required at the storage level because the storage is shared between the instances, so it's just a failover to the read replica. The storage level recoveries are transparent because there is this peer gossiping happening all the time. If there is availability zone failure or if it's a segment failure, it auto recovers without the user knowing what's going on. It's transparent to the application completely. Instance crash, again, since the storage system is transaction aware and the log records are applied all the time asynchronously in parallel, there is no recovery required during the instance crash. So backups are also automated in Aurora. There is a continuous backup snapshots getting taken periodically and asynchronously in parallel, and the logs are also getting streamed to S3 with no impact to the system. So while it is writing to the storage system, it is also writing data to S3. In case a failure occurs, it should be able to recover pretty quickly. When you do the restore, appropriate snapshot segments are restored along with whatever log streams are needed to do the complete recovery, but the log streams are not applied right away. After the restore is complete, while the system is still in use, log streams are getting applied asynchronously while the system is being used. Another 2 key features that a lot of customers ask for when they're moving their workloads to the cloud is encryption and auditing. Encryption is provided in Aurora for data at rest. You can do an instance level encryption using KMS keys. Customer can manage their own KMS keys to encrypt the data at rest for the instance. And for data in transit, you have SSL encryption for all the client connections, and that is provided out of the box. Auditing, we do have this extension turned on called PG Audit that would enable you to create the audit logs for all your compliance purposes. And you can turn it on at any level for activities that could be related to access or DDLs, reads, writes, whatever it is. You can turn it on for all of that. The logs, the way you access them, you have two options. One is either through CLI, or you can also access them through console. This is a snippet of how you configure the audit logging for the database. This is through the parameter groups. So you would create a new parameter group. You would make a change to the very first parameter called pgaudit.log to define what audit logging you want to turn on there. Again, you can have it for all, or you can just have it for, let's say, access purposes. Shashi is going to cover the cloud migration plan.
Thank you, Sandeep. So now that we know that Aurora Postgres supports or provides most of the solution that I asked for. Now let me just briefly cover some of the cloud migration plan that we have. Again, going back to the mission critical and the business critical. So as I mentioned earlier, the mission critical applications are hosted on multiple data centers. So the migration strategy for mission critical application would be like we take one data center at a time and one system at a time. We move the system and the database to the cloud, and once the data is moved, we need to set up a replication between the on-premise, the database in data center 1, which is on-premise, and the one in the AWS cloud. The reason being, when we cut over or move the users to the AWS, and in case if we foresee any issues and that cannot be resolved within a certain period of time, we would like to come back to our on-premise so that we really don't impact the business. So once we have this replication set up, and since this is a mission critical application, we have an option to move or transfer some of the users, real-time users who are currently using the data center 1 to the AWS, to the systems in the AWS, and run both the systems in parallel for certain amount of times, number of days. And if you see any issues, if we have any SQL performance issues or any of the business functions that are not run properly, once we fix all those things, and then we do a final cutover. So the final cutover is like we move all the users running on the data center 1 using the system on data center 1 to the AWS cloud, and then we shut down the on-premise, the systems on the on-premise. So one thing to notice here is once we move this data center 1 to one of the AWS region, we end up in a hybrid kind of model. So we do have the systems running in AWS cloud, but we also have the data center 2 and 3, which are like on-prem, and they are also like fully functional and production. So again, one of the thing and ask here is we need a product which can replicate the data between this hybrid model, between this multiple types of operating systems and different types of databases that we have. So we call this architecture as N+1. N is nothing but the on-premise data centers that we have, and +1 is the one in AWS cloud. So moving on to the business critical, as you know, at any given point in time, only one data center is active, and the workload that we have for the business critical application is mostly batch. So the strategy is a little different here. So we migrate all the data from the data center 1 to the one of the region in AWS. The batch process, which are kind of a majority of the workload, so we run this batch process in both the system, one in cloud and one in data center 1. Again, this is purely for the backout purpose. And once the data has been caught up, we cut over all the users, and in this case, the users are mostly internal to the company, especially from the marketing team, revenue assurance team, and the finance team. So we move all the users from the data center on-prem data center 1 to the AWS cloud, and if we see any issues, we try to fix them right over there, and then we move forward. So the next step would be once we are comfortable, we shut down the systems in data center 1. And in this case, at the end of the day, when we go live, all the systems for a business critical type of applications will be running in AWS cloud. So this is kind of a beginning stage. And as far as the end state is concerned, we are looking for two different options. Option one is we would like to retain the on-premise architecture design that we have today. Like we have the data center 1, 2, and 3, we would like to exactly replicate this architecture and move them to cloud into region 1, 2, and 3. And the way there are two architecture designs that I talked about. One was the local HA, we use the read replicas to provide the local HA, and for the DR solutions, each of these region systems in region 1, 2, and 3 play kind of a DR system for the other region. And with this design, we continue to maintain our on-premise systems, and with all the checks and balances in place, we also meet the SLA that the business needs. I would like to call upon Sandeep to talk about option 2.
Thanks, Shashi. So option 2 is the way Verizon has their regional databases, merge them into one cluster and have just one cluster manage the entire workload. In this case, the additional traffic that is coming into one cluster can be handled by the reader endpoint. And this is pending the testing. We have not done testing around this, but this is another option that Verizon is looking at from cost-saving perspective. They don't need to run 3 different clusters to manage their regional data. They can use pretty much one cluster, and then they do a cross-region copy as well to keep the data for DR in another region. And even there, they can use those read replicas for their read traffic. Now let's talk about the use case that we tested for Verizon. This is a big one for them. What it does is, this is a batch application that processes over 1 million customers a day. It's a very critical application. It has to finish within a certain SLA. So we tested this, we set this up in AWS. Let's first talk about the current architecture, and then we will see what we did in AWS to test, and then we will see what were the results. We do have the comparable results as well between on-prem and AWS. So this follows their typical business critical architecture pattern. Each region is processing their own its own data. Current process is written in stored procedures, and this is how the process flows. There is an external process that is loading the data into the staging tables. Once that is complete, another process kicks in and processes the data and loads the processed data into the final tables. There are multiple threads that gets kicked in to run this process and complete it on time. So let's see how this looks in AWS. What did we do there to gain better performance? So on cloud, the process was redesigned and rewritten in Java. Now the external process, instead of dropping the data onto a shared drive, the external process is now dropping the data into S3. EC2 instances were used to kick off the process that loads the data from S3 to the staging tables, and then from staging tables to the final tables. You will see that the EC2 instances are in the auto-scaling group. This is to accommodate additional processing if needed. And this could very well be a Lambda in the future architecture, just eliminating the need to have EC2s completely for processing data for this application. The application module was rewritten to send the write traffic to the writer instance and read traffic to the read replica. That gave us quite a bit of performance improvement there. From the database's perspective, the architectural pattern, we kept it the same. One cluster for each region for this testing, and then each with a read replica for HA and DR capabilities. And it is also helping us run the process faster. This is the new process flow. There is a Lambda event on S3 to flag the process to load the data into the staging tables now. Once that is complete, another process kicks off to process the data for each region, again, in parallel. So there are multiple threads running to process this data and load it into the final tables. Here is a comparison between the two runs. In this case, smaller is better because on Aurora, it took at least 40% less time compared to the run that we did on-prem. We do have the processors listed, number of cores listed at the bottom of the slide. We had 32 cores on Aurora versus 56 cores, but obviously the cores are newer compared to what we have on-prem. So we did have some learnings while doing this POC. The learnings were mostly around DMS. We use DMS to migrate the data for this POC testing. One of the big ones is when you migrate a partitioned table to Aurora, you get a single table. That's how DMS works. So we had to go back and redo that and convert it into the partition table again to gain performance there. The other one is the data type conversion. It's not optimal. The reason I say that is because when it's converting a number data type, it's converting it to numeric in Aurora Postgres, and numeric is not one of the best data types to store your data for performance reasons. So we had to go back and change that numeric data type, convert it into integer to get better performance. And especially if you have referential integrity, integers are much better compared to numeric. The other small issue we got, which we fixed it right away, is around the case conversion of the object names. So when it's bringing these objects from the source system, it's bringing them uppercase, whereas Postgres defaults to lowercase. So there is a setting in DMS that you can do to make that conversion. Once you do that setting, you're all set. Now the last one is the key. We did use performance insights to tune this system to run it on Aurora. It gave us insights into the slow running queries. We were able to easily figure out which ones are taking more time, and we were able to pretty much tune them pretty quickly once we know which ones are taking longer. So we're going to talk more about performance insights. Mark is going to cover that section. Thank you.
My mic, there we go. So yeah, I would love to talk about performance insights, which is frankly a feature that I've wanted to write for 35 years. Imagine you have a database and imagine you can't figure out what's going on inside it. I mean, it's never happened to any of us, right? So what we did in 2016 is we tried to remove some of the shrouds from RDS, and we added enhanced monitoring, which gives you the ability to see 53 operating system metrics in real time, down to 1 second granularity. And this is stuff like top and VMstat and IOstat. And then as soon as we were done with that, we built this huge infrastructure which records literally millions of data points a second and lets all of our RDS customers look at those data points and do analytics on those data points. And they're available either via the console or via API. And so we went, wait a second, The next thing we wanted to do was do this for SQL. So RDS Performance Insights just went preview about a month ago with Aurora Postgres, and it actually lets you see, as you can see on the bottom of the screen there, it lets you see the actual SQL statements going on your database and what type of activity they're doing. And this lets you dive in. You can actually shrink or expand that graph back to 35 days and see what's going on. And so I think picture's worth 1,000 words, so a video must be worth 1,000,000. So let me see if I can show you the video now. And we are up, and I think I just need to hit.
Today, I'll walk you through how to access and use the Performance Insights dashboard. To access Performance Insights, click on Instances in the top left. What I want to bring your attention to is a new column called Current Activity. In this case, we have one database with high load. Part of that load is in the red state. So let's click on that bar, and it'll take us to the Performance Insights dashboard. The Performance Insights dashboard is divided in two parts. The top part shows the load on the database over time. And the bottom half shows the top SQL ranked by the amount of load they're putting on the database. And in this case, we can see that some load has spiked up in the past few minutes. And it's this color yellow. Now what is yellow? We can look at the legend to the right. I see yellow is CPU. So it looks like we're having CPU starvation. Now how do I identify the bottleneck? We identify the bottleneck by looking at this dashed black line. And that represents the number of cores on the machine. We can only have as many sessions running on the database as there are cores on the machine. And if the load goes above the dashed black line, the number of cores, then we know that we're waiting for something. Now that could be CPU, or it could be other resources, such as locks, I/O, commit writes, or others. Now where is that load coming from? We can look at the top SQL on the bottom. And in this case, our load saturation is coming from CPU. So we want to find the SQL statements that are consuming the CPU. In this case, the only one that looks like it's consuming much CPU is the third line down, all in yellow. It's a select foo3. Now I know as a DBA that it'd be worth my while to spend a day tuning that SQL statement, in this case it's a procedure, to cut down on the amount of CPU it's using and eliminate the CPU saturation on this instance. Now I can zoom out to larger time frames. If I click on 6H, that's 6 hours. And in this case, I see that there are spikes earlier. Now I can select a spike by clicking my mouse and dragging across the spike. And now I'll zoom into that load period. And in this case, I no longer see CPU saturation. I see some other wait event. So we're waiting for something. Now I can look into the legend, and I see the top wait event, blue, is IO:XACT sync. Now, we can look up the definitions for this wait event, and it turns out this wait event is waiting for writing changes to the database to stable storage. Now, what SQL statements are waiting for this? I look in the top SQL, and I see the first two statements are the ones spending almost all the time waiting for this. Now, what are those SQL statements? Those are insert statements, which makes sense because we're waiting for changes to be written out to stable storage. In this case, I see that the insert statements are inserting, the first one inserts one row into the table at a time. And what happens is by default, we have implicit commits. So after every insert statement, we have to wait for a commit and guaranteeing the changes are written to disk. Now, if I want to optimize my application, what I could do is have insert statements that do many rows in one single insert statement. Now we can look at the data with other dimensions. So by default, it's weights on top and top SQL on the bottom. But on the bottom, I can also choose to look at the top weights, which is the first one, and see which weights I've spent the most time on. We've already seen SQL. I can also see it by hosts. In this case, I have 2 hosts, and I can see that the load is well balanced across those hosts. Now, if I had an application server that might have had the wrong version of the code on it, it might be taking up higher load. And I can see immediately across my application fleet if any of those instances are generating higher load on my database. I can also click on users and see which users are putting the most load on the database. In this case, my application is running all as one single user. We've looked at the top table on the bottom half of the dashboard by different dimensions. We can also use those same dimensions on the load chart on the top. So if you look at the legend, to the top right of the legend, there's a line that says slice by. By default, it's weights. I can click on it, see other dimensions I can group by. So I can, instead of weights, choose SQL. Now the load on the database is exactly the same in the chart. What we're changing is the stacked colored areas. So the stacked colored areas were weights, and now they're SQL. So I can see the load by SQL over time. So for example, those SQL waiting for the writes to stable storage were not steady state. They came and went. Whereas some other SQL statements had very stable load on the database. I can also do it by hosts. Now we saw that we have two hosts that look like they were putting on similar load onto the instance. In this case, we can see one host had a steady state and another host put on a heavier load during a certain period of time. And finally, we can see the load by users over time. In this case, we just have one single user. So we've seen how Performance Insights makes it easy to see the load on an RDS database and to both identify when there are bottlenecks and where to act if there is a bottleneck. Thank you for watching.
So this will all be up on the web, and you can take a look at it. This video is also available on YouTube, but think about how you could tune your databases by doing this. And now I'm going to hand it back to Shashi for the final part of the presentation, where we talk about our roadmap.
Thank you, Mark. So let me just talk about some of the challenges that we have faced during our journey from the private cloud to the public cloud. So I will highlight a couple of them here. So one of the things is unlearn and learn. So these two are like very interesting terms. So when I say unlearn, what I'm referring to here is we need to unlearn the traditional way of doing things, the way we are doing our testing and the code deployment today, and we need to think more on the automation and the DevOps model for faster delivery. And as far as the another learning aspect here is the cloud technology. AWS has so many products and services that are must for us from the Verizon point of view that not only helps us to migrate our systems to AWS, but in order to run them successfully in the cloud, we need to understand all these new technologies that we have today in the public cloud. CI/CD, continuous integration and continuous deployment. With our migration model, when we move one of the systems to the cloud, we end up maintaining like two different versions of the code base, one for systems running in AWS and the other one for on-prem. So there is an extra level of testing and the UAT acceptance procedures that we need to go through just to make sure that both the code base work successfully in two different platforms. SCT 8020. So schema conversion tool. So we did use this schema conversion tool to review some of the applications that we have in-house just to check the portability of these applications to Aurora, Postgres, or MySQL. So one of the things we noticed that 80% of the code and the data would be easily or quickly automatically migrated using the DMS service, but there is still some additional 20% of the data and as well as the application code that needs some manual intervention to make it compatible with Aurora Postgres. So we need to spend some extra time and energy to make those code changes and make the systems available, ready for cloud. So Mark, here's the second laundry list for you. So some of the nice to have features that we need for the systems in Verizon and the applications in Verizon to run successfully in cloud. I think I have emphasized enough on the need for the cross-region replication. So if you remember the on-premise architecture that we would like to maintain, we have the 3 data centers exactly replicated to the 3 regions. So we need the cross-region replication between AWS region 1 and 2 for disaster recovery purpose. IAM authentication. So today the way we are maintaining all the user base is we are creating all these individual users within the database, and then we keep track of it on periodic basis. But what I would like to see is I would like to maintain this user base at the top level, which is the IAM level. And this is just to simplify the way simplify the security procedures and policies for the databases and protect them in a much more efficient way. Resource management. Cloud is all about saving cost. So I would like to see a feature wherein I should be able to restrict the users from running some bad jobs and long-running SQLs and use the CPUs, I/O and the CPUs. So that we need to control the ad hoc SQL that is being run today. And last few, there are a few more, Mike. So all right, so view back in time data. So Aurora has a feature wherein we can take the complete database back in time. But what I'm looking for is I would like to extend this feature to at the object level, wherein this will help me to fix some of the minor data issues that we have. I can take that object back in time rather than taking the entire database and impacting the application to a certain extent. So partitioning options, most of our applications and the databases we are using composite and hash partition, and that is purely for performance reasons and as well as for supporting some of the application functions. So we definitely need these features in Aurora Postgres. And the last but not the least, the SQL execution plan. This has been a very kind of a common issue wherein the SQL plan changes in the middle of the day and it impacts the application. So I would like to see a feature wherein I can lock down the critical business SQLs to avoid any disruption to the business due to the bad execution plan. So I was having a conversation with Mark this morning, and he did tell me that he's going to give me all these features by end of the day today. So let's hear from him.
Well, I did say end of someday. I'm not sure about today. So let's, in the interest of time, let's go through some of the roadmap for Aurora Postgres. I want to flip back at the end. I might flip back and review a couple things he said. But let's talk about where Aurora Postgres is. We launched on October 24th in 4 regions. We are very proud to say that we are the fastest growing database product in AWS history, building on the success of Aurora MySQL. Now, some of you might say, wow, what a corporate thing to say. I actually don't care about the revenue. I don't care about all that. I care about the fact that in the first 5 weeks of use, we have so many customers using the product. It's really exciting. And at AWS, we think about usage and adoption far before we think about revenue. Then we also, because it's reInvent, we have to have some launches. We launched 4 new regions this week. We launched fast database cloning, which is the ability to look at your database and freeze it, and have another database stood up within 30 to 90 seconds, depending on your database, and actually start doing reads and writes on that database immediately without doing a snapshot and a restore. We also announced eligibility for inclusion in BAAs and HIPAA. And what's on the roadmap? Well, there's more Postgres extensions. There's Postgres 10 compatibility, which is going to help with a lot of the partitioning stuff Shashi wanted. There's a lot more regions this month and through 2018. There's going to be more authentication options, which is going to address not only the stuff that Shashi wanted with IAM, but even more ways to authenticate against our databases. And then the other thing I'd really like is, what do you guys want? You see that email address, aurora-pm@amazon.com? That goes directly to my product management team. Use it. And then finally, there are 4 features being announced in Aurora Postgres in Andy and Werner's keynotes, and I would get in trouble if I announced them right here, but you are totally welcome to go see those and have questions about those, and then email that Aurora PM alias. So with that, I'd like to apologize for us getting a late start because of our AV issues, but now we'd love to take questions if you have any. I'm sorry?
7 terabytes?
What database size did you migrate?
It was a 10 terabyte database. Repeat the question, please. So on-premise, it is Oracle database that's running. It's a homegrown application.
So what is Amazon doing from a support standpoint so that these ISVs actually start supporting Aurora?
So the question was, what is Amazon doing to help ISVs support Aurora? We have a program that is reachable at Aurora-PM, and we're working with ISVs directly through our partner program aggressively, and we're working with customers. You can understand this is a bit of a chicken and the egg situation. We, in the last year, are starting to see aggressive certification efforts by many major ISVs. So if you have one you'd like, send us an email and we'll start looking into it, or we'll give you the status of where we are with it. Other questions? I see one at the mic even. Can you turn up the house lights a little bit?
Yeah, so I was curious why Postgre instead of MySQL for Verizon? Just not trying to troll, but just curious.
Can you repeat this?
So the question is, why did we choose MySQL rather than Postgres?
Verizon did.
Yes, why did Verizon choose?
So I think it's a choice that we have for every customer, right? So as I mentioned earlier, I use this schema conversion tool to run against the application running on the on-prem, and we ran the report for the schema conversion tool for Oracle and as well as for the Postgres and as well as MySQL. We did see that the Postgres gave was much less complex. I was able to convert like 80-90% of the data automatically, and basically the plan is like when I move the systems to the cloud, I'd like to simplify the whole process. I really don't want to rewrite or make more code changes or the database changes. So that was one of the reasons we picked up Postgres for this testing.
So for those of you who are not aware, the schema conversion tool has an assessment mode where you point it at your actual database, it goes through your database, and then it will give you a report of how well it will do converting to MySQL or SQL Server or Oracle or Postgres.
Can you guys walk up to the mic to ask question, please? There is no mic. Okay, go ahead.
So, my question is regarding concurrency. What are the limits on the number of read replicas that you have? And I believe there is an ELB in front of it, right? Because that's how you're able to distribute the load quickly.
So the question is, what's the level of concurrency for the read replicas, and is there an ELB in front of it?
Yes, there is a ELB in front of it. There is no concurrency limit. You just test it out for your application, figure out where it breaks. For this particular use case, we had 120 concurrent connections going on the writer instance and another 120 going on the reader instance. And we didn't see any performance issues because of that.
The reason I asked that question is that I'm looking at it not from an OLTP workload, I'm looking at it from a DW workload. I think you're supporting 64 terabytes. If you have smaller data warehousing workloads, why would I not go from full SQL as opposed to, because you guys can still support it's just that columnar is not. That was the motivation.
So the motivation behind the question was, what about DW workloads? And I can answer the unspoken question, which is Aurora Postgres is also great at light analytics. We believe that to use the right tool for the job is the right choice. So for heavier analytics, we would strongly advise Redshift. At the same time, we see customers doing light analytics along with their OLTP workloads all the time. Next question, please.
Yes, sorry. During your Oracle migration, how did you handle PL SQL? Did you migrate your PL SQL to Postgres?
So that was part of my slides. We converted the PL SQL code to Java in its entirety before running it on Postgres. One of the asks from Verizon is they want their code to be database agnostic. So if they want to port it to something else at a later stage, they should have that option. So the way they are looking at this migration is move it out of the database completely, their business logic, and build it in something else.
We're looking at doing the same thing, but we do not have quite a few resources to do all the migration. We're going to migrate some of that to ETL, but is there an option to move that to Postgres stored procs?
So the schema conversion tool will actually make an attempt at converting PL SQL to PLPG SQL.
Okay.
And if it's basic data model type conversion, it does really well. If people have put your business rules in the database and used what I would call some of the more extensive features of PL SQL, then it will highlight those with comments in the actual PLPG SQL about where you may need to make modifications.
Okay, beyond that, I guess you'd have to do manual intervention.
I'm sorry?
I guess beyond that, you'd have to manually do that type of work. There aren't any other tools to help you migrate.
So the schema conversion tool actually has a screen you can make those modifications on. At the moment, we're not aware of any other tools which do it as well as SCT does,
Okay.
frankly. But we are always working on SCT, and in fact, as people translate things in SCT, we track usage of that, and we notice what it's not converting, and I bet you can guess how we build our backlog for the team. It's from things that don't convert.
Yeah, so next question is on the performance insights. Is it available only for Postgre or it's also available for Aurora MySQL?
Great question. So Performance Insights is available for Aurora Postgres right now. Aurora MySQL is imminent. Not really sure when, but imminent. And then the other engines will be coming in the first half of 2008.
So based
It will
on the,
be available on all 7 RDS managed engines.
right. So based on the demo that you have shown, is it kind of modeled on the Oracle OEM? Similar concept like wait interface and all those things? Similar to that?
Well, I think it's working on the active session, the ASH stuff with
Yeah,
Oracle,
ASH stuff,
and
yeah.
giving that kind of concept and that kind of view, exactly.
Okay, so it's basically it's improving tool. Like it's like,
So in Oracle, obviously, you have the X dollar and V dollar views, and when we port it over to Oracle, of course, we're going to use all that stuff too.
okay, thank you.
My question mostly for these folks from Verizon. I know you use Oracle databases a lot. So do you think at this point you're ready to switch all your Oracle applications to Aurora database?
The answer would be like yes and no, because this was one of the successful POC proof of concept that we have done. But there are a few more applications that I'm working closely with Sandeep for doing the performance analysis, proof of concept. But on the other hand, we are also, at this point, we are doing some analysis on our inventory. We are going to each and every data center, what kind of systems we have, what's the storage, and what's the database size. So we are evaluating all those things at this point, but we are not there yet to say yes, that we are ready. So we are working towards that.
So to add to that, I don't think Aurora Postgres is the answer for every single workload. And this is why, while working with Verizon, I have been telling them, test out every single workload before you say Aurora is the answer for you. It may not be in some cases, because they do have a lot of data warehousing kind of setup as well, heavy batch intensive applications as well. Maybe Aurora may not be a good option. So you really need to test it out, figure out what works. If not, then we have other options as well.
So the question was, would you consider other databases, or did you consider other databases outside of Aurora?
You want to answer that, or you?
This is the reinvent, so I would say no.
No. So I'm sure he did an analysis, and we could talk and you can do that. On that note, we're actually going to shut down the stage, and we're going to take questions over here on the side of the stage. So come on up with your questions. We also have our senior principal engineer and the founder of RDS, Grant McAllister, up here. So if you have any deep and probing questions about RDS, this is the time. Thank you so much, everybody.
Thank you.